All right, y'all. So this wants us to use the end behavior diagram to describe the end behavior of the function. So we look at the degree and the sign of the lead coefficient. So the degree is my highest exponent, which is 6. So I got an even degree of 6. And then I got a negative pi. So that means my lead coefficient is negative. And y'all, let me show you what you want to use on this. So we're even degree, negative lead coefficient. So I would use that chart we had that I gave y'all. So even degree, and it was a negative lead coefficient. So y'all, even and negative puts me where both ends are going downhill. So we want to pick the one where they're both ends are going downhill for that one.
What section is that in?
Oh, this would have been the very first thing we hit. What was that, like 8.1?
Okay.
Could you go back to that paper for just a second?
Uh-huh. Yeah, we made this in 8.1 and had a section going over it. Actually, I used this for the first 2 sections, basically.
Mm-hmm.
And so remember, it compares the even and odd degree, and then it looks at the positive lead coefficients and negative lead coefficients. So determine whether you're even or odd, and then whether you're positive or negative on that lead coefficient.
And you said you always take the highest degree?
The highest exponent. There you go. All right, let me try to catch everybody in here. Just had a bunch of people hit me up. All righty, so y'all, I'm going with even degree, odd, puts both ends going down. So let me go math lab. And let's see, both ends going down. We're picking C on that. All right, y'all, so C, and then we go to next. So the first 2, we're doing that chart right there. So this one, same thing, negative 4.3 x to the 4th plus x to the 6th plus 0.2 x to the 7th. So the degree is the term with the highest exponent. So y'all, that's going to be that 7. This one's just out of order. So the 7 is odd. The lead coefficient is going to be the 0.2. Remember, the lead coefficient is always in front of the variable with the highest exponent. So let's see. I got you.
Letter B.
So we're odd and we're positive. So let's see. So that's going to go uphill left to right. So that would definitely be B. All right, let me see who's coming in. All righty. So yeah, odd and positive. Remember, if you went back to your chart, odd would be this row and positive is the top one, okay? All right, so that was what the deal with those first 2 were. So now we're actually going to start finding zeros. So this is number 3. They want me to find the zeros and state the multiplicity. So y'all let me write down that f of x equals x squared minus 4 to the 3rd. So I'll work this by hand, and then we'll come in and we'll pick A, B, C, or D on that one. So I will say this. That exponent 3 sitting on the outside, that is our multiplicity. Okay, because that's going to tell me how many times these zeros are occurring. So since we got that exponent out there, remember, that's like writing x squared minus 4, x squared minus 4, x squared minus 4. So we get the multiplicity from the exponent on the outside. We get the zeros from solving this factor on the inside parentheses. So y'all, set that x squared minus 4 equal to 0. Now, 2 ways to solve this, and I'll actually solve it both ways for you. The first way to solve this is to add 4 to both sides and take square roots. So I get x squared equals 4. And then I'm going to take square roots of both sides. Now remember, since I'm taking the square root of that number, I got to use my plus or minuses. So that I get my x is equal to a plus or minus square root of 4 would be 2. So you can solve it square roots. And on this one, I'll actually show you the other way you can solve this one. You could solve this by factoring. Anytime you got 2 terms like this being subtracted, that's probably the difference of perfect squares. So the x squared would be an x and an x. Perfect squares always factor into conjugate pairs. So 1 plus and 1 minus. And then the square root of 4 would be 2. So then y'all, I would set both them equal to 0 and solve those. So the first one, I would subtract 2 from both sides. I get x equals negative 2. And then on the second one, I would add 2 and get x is a positive 2. So look, no matter which way you solve that, you're going to get a 2 and a negative 2. So solve it by, I'll probably keep solving mine by square roots because it's quicker. But I wanted to show y'all that factoring also worked on this. Okay. So look here. Our zeros are 2 and negative 2. Each of those has a multiplicity of 3. All right, y'all. So remember that. Plus or minus 2 and multiplicity of 3.
So why on the second one you got a minus 2 and a 2, but on the first one when you did the square root of 4, you just got a positive 2 on the first example? Will the positive 2 alone work, or will we need the negative 2
Right here?
Yes.
Oh, I got a plus and minus because that minus is under there.
Oh, you know what? I'm tripping. You sure right. You told us. Okay. Okay.
Yeah, so that's sort of shorthand for writing both of those as one answer.
Got it. Okay.
Mm-hmm. So our zeros would be 2, negative 2, and they might use the plus or minus. And then each has a multiplicity of 3. Okay, so that's what we're going to be looking for when we hit that math lab. So y'all, let me go to math lab real quick. All right, so plus or minus 2, multiplicity 3. That's wrong. B is wrong. Looks like C there, don't it? So C it is, and then next. All right, y'all, so let me write what I got here. F of x equals negative 9 times x minus 2 to the third times x plus 1 squared times x to the fourth. Now notice what they got for the answers. The 0, 2 has a multiplicity blank. Blank is a 0, a multiplicity 2. And then the remaining 0 is blank. It has multiplicity blank. So these ain't bad, but let me show you what's happening to these so that you don't make mistakes on them. To get the zeros, I set the actual factors equal to 0. Now, y'all see that negative 9 does not have a variable with it. So we sort of scratch that negative 9 out. It does not determine any zeros since it don't have a variable behind it. So the ones that will determine my zeros are going to be the x minus 2. So I'm going to set that equal to 0. The x plus 1. I'll set that equal to 0. And then this x to the fourth, I'll set x equal to 0. That's how I'll get my zeros. Now the multiplicities are going to be all these exponents on the outside. So whenever I get out of x minus 2, we'll have multiplicity 3. whatever I get from the x plus 1 will have a multiplicity 2. And y'all, this one's already done. X equals 0. So that means 0 is 0 with a multiplicity 4. So let's get these two. And if you notice, from these factors, all we're doing in the long run is changing the signs. So when we add 2, my 0 will be a positive 2. And then where you got the x plus 1, we'll subtract 1 and get x is a negative 1. So my 0 of 2 came from this. It has a multiplicity 3. So that has a multiplicity 3. Negative 1 came from this factor, has a multiplicity 2. And then 0 came from that factor, which means it has a multiplicity of 4. All right, y'all, so let's go put this in where we need it on our answer blank. So the 0, 2 had a multiplicity, we said, of 3. Because it came from this first parentheses here. All right, y'all, look at this. Blank is a 0, a multiplicity 2.
Negative
one. Negative one.
So y'all said negative 1. And then the remaining 0 is blank, and it has a multiplicity blank.
0
and
and 4.
There you go.
So, Mr. Eugene, we basically don't have to. If we could just look at the exponents. We don't have to do everything you just did, right? I'm just asking, like, can it work like that?
Now, so what I would
like 2 has the exponent of 3, and 2 has
exactly.
Yeah.
The only thing you got to watch out for on these problems is like when it said blank is a 0 of multiplicity 2, that second sentence. Make sure you don't put positive 1 because the factor is a positive 1, but the 0, you got to remember to change the signs on those zeros, though. Okay.
Okay. But other than that, it can't work like that as long as we remember to, like you said, change the signs.
Yeah, because the multiplicity.
Like -2, okay, yeah.
The multiplicities will always be the 3, the 2, and the 4. But just remember that x minus 2 has to be come out as that first 0 they said of a positive 2.
Okay.
All right, now I think 5 is the one where they're 5 is the one where they're giving us the 4-term polynomial. So f of x equals x to the 3rd minus 7x squared minus an x plus 7. So they want me to find the zeros and the multiplicity. Now, y'all, I'm going to tell y'all the truth on this one. Y'all's is going to be really similar to what I get. The only difference they're going to change up is my 7s. Y'all might get like a 5 or a 3 or any other number. But your problem will work exactly like mine other than the 7s, okay? So this is one of those 4-termers where we separated it into 2 groups and we did what we called factor by grouping. So factor by grouping, we had to factor out the greatest common factor from each of these 2 groups. Now, so y'all are going to have the same exact greatest common factor on the first 2 terms. So x3, 7x squared. The greatest thing they got in common is an x squared. And everyone we done, even in the homework, on the first 2, you factored out an x squared. So that left me a x minus 7 in parentheses. The second GCF over here had the same sign as the 3rd term here. So since my 3rd term's a negative x, my second GCF will be negative. Now, what's the only thing we could factor out of an x and a 7?
So 1.
A 1, perfect. So y'all, guess what? If you factor out a negative 1 from both of these, that negative divided by negative makes that a positive x. And then that positive 7 divided by negative 1 makes that a negative 7. So notice at this point, my parentheses match up perfect. So y'all, here's the thing. Y'all are going to get an x squared and a negative 1. Like I said, the only thing different at that point will be those 7s.
Mr. Eugene, you said divide. Did you mean to say that?
Yep. when you factor out the greatest common factor, it's like you're dividing everybody by that GCF.
Okay.
It in that stuff, it sort of undoes the distributive property where you were multiplying to create them. So undoing them, we're just sort of like dividing them out. And remember, when I divide these x's, I'm just subtracting the exponents, right?
Mm-hmm.
So 3 minus 2 left me to 1x. Here, the 7x squared divided by x squares. The x squares canceled, leaving the negative 7. And then over here, we just divided those both by negative, which basically all that did was change the signs. So at this point, the parentheses got to match up. So since the parentheses match up, we're going to factor that out as the x minus 7. So think about this, y'all. If both of these have an x minus 7, and we factor that out as a GCF, what would be left to go in my second parentheses?
X minus 7.
Well, we're factoring both of those x minus 7s out like a greatest common factor. So we're pulling them x minus 7s out. So what would be left to go in here?
The x squared minus 1?
The x squared minus 1. So y'all remember, the parentheses match, they make up one factor. Everything else makes up the other factor. And then at this point, since we're factored, we would set that equal to 0. So here's another question. These are going to be how I get my zeros with that x minus 7, x squared minus 1. What exponent is behind both of these parentheses since I don't have a number there?
1.
So definitely a 1, y'all. So treat that like 1 sitting behind both of those parentheses. Which means when we're done, all of our zeros will have a multiplicity of 1. So now, let's get those 3 zeros by setting our factors equal to 0.
I'm sorry, I missed that one part. The ones on the little exponent ones outside the parentheses, what is that from?
That means that's my multiplicity. And since I don't have any exponents outside these parentheses, it's got to be a 1.
Okay.
So basically, I had one of these factors and then one of these factors here.
Okay, got it.
Although this factor is about to get me 2 answers, though, right? Because of that exponent 2 there.
Right.
All right, y'all. So this one will add 7. And I get x is a positive 7. This one here, remember, you could factor this or do the square roots like I did up here. If you factored this, you'd get an x plus 1 times x minus 1. But I'm just going to hit it with the square root real quick. So I get x squared equals 1. I'm going to take square roots. So I'm doing a square root of a number. So remember that plus or minus on that so that you can get both those answers. So this gives me x equals a plus or minus. And y'all, that's nice. The square root of 1 is 1. But it is perfect squares, so you could do it like I did here. Put a 1 and a 1 instead of those 2s, okay?
Okay, Mr. Eugene. So with this one, can you go all the way back up to the top for me? Because I don't, maybe this is probably the one I skipped yesterday because I didn't know we divide with these at all. So
well, think about this. Let me show you this. Let me show you this real quick. If I had an x squared times x minus 7. So I'm distributing this x squared real quick. So this x squared times x gives me what, an x to the 3rd? X squared times negative 7 gives me a negative 7x squared. So I did the distributive property. I multiplied this stuff, right? And when I multiplied these x's, I basically added exponents. So 2 plus 1 gave me 3. And then 7 times x squared was the 7x squared. So when I say GCF, greatest common factor, we're undoing this distributive property. So when you look at this x to the 3rd and 7x squared, the most that they have in common are 2 x's. right? This one had 3 and this one had 2.
Mm-hmm.
So x squared was my greatest common factor on that. So here's what I did over here. I write my greatest common factor, and then I'm figuring out what goes into parentheses. Well, what goes into parentheses is what you get when you divide x3 by x squared. So let's think about that. x3 divided by x squared. What will that give me?
Just an X.
Just an x. Right, then we got our minus. And then we got 7x squared divided by that x squared. Well, what happens here?
7X. Or is it 7X squared?
Well, remember, you got an x squared up here. You're dividing by x squared. So since these terms match completely, don't they just
So
cancel out?
Oh, okay. Those are cancel.
And all that's left is my 7. So remember, we are dividing those to get back to the way we started when we would have multiplied them, okay?
Okay, and then the -1 just came from when you did -1 and then did the second one.
Yeah, because they didn't have nothing in common but that -1.
Okay.
Because x times 1 would give me x. 7 times 1 would give me 7. And it always has to match that. Since that x was negative in the third spot, the GCF has to be negative. If that would have been a plus x, then this would have been a +1 when I factored it out, okay?
Mm-hmm. Okay.
All right, y'all, so let's see. So our zeros were, what I get, a 7, comma 1, comma -1. And each of those had a multiplicity of 1. Now, number 5, every time you should get just a multiplicity of 1 on that one. All right, y'all. So let me remind you on this. If a 0 comes from a factor that has an even exponent, then the graph is tangent to the x-axis. If the 0 comes from a factor that has an odd degree, then that means that 0 crosses the x-axis. So let's look at what we got. We got P of x equals x minus 3 to the 6th, x plus 1 to the 5th. They're saying true or false, this graph of this polynomial function, y equals P of x, they're saying it crosses the x-axis at 3, 0. So you got to figure this out. Which of them two factors would have gave me a 0 of 3? Well, that would have had to come from the x minus 3, right? So it came from the x minus 3. It has a 6 as its degree.
Mhm.
Or multiplicity, I mean. So since it's got an even multiplicity, it's not going to cross the x-axis. It's going to be tangent. So this one is actually false. So I would go to A or B is false. But y'all look at that. This one says, A says the exponent 6 is even, which is true. B says the exponent 6 is odd. Well, that's false. So we have to go with A. It's false because the exponent 6 is even and it should be tangent. Okay? So remember, even multiplicities are tangent. Odd multiplicities cross over. All right, so that's all you're looking at. Make sure you get the right factor when you look at that 0, okay? So the other one they could have gave me was -1, 0. -1 would have came from the x plus 1, okay? So on that and figure out the factor and then look at that multiplicity. Now this one should be y'all's give me. I got f of x equals -6x minus x to the 4th. Y'all, what's the maximum number of real zeros I can have? Oh, y'all slept since this one. So remember this. The maximum number of real zeros is
4.
equal to the degree. So there you go. That was at 4. Well, if the maximum number of real zeros is 4, what's the maximum number of x-intercepts?
4.
So that'd be 4. Those two got to match. Remember, zeros and x-intercepts, or
Oh,
basically
and the turning points subtract by 1. So it'd be
exactly. So what are you getting?
3.
3. So the first two exactly equal the degree. The turning points, take that 4, subtract 1, and get me a 3, okay? All right, y'all. So let's see what they got for 8 here. All righty, so 2 ways to do this one. So let me write this down. H of x equals x minus 3, x plus 2, and x minus 4. 2 ways I can either graph this or I can use my in behavior stuff.
Mhm.
So now if I graph it, y'all see all these graphs are going from -10 to 10 on the x's. And the y values are going from -100 to 100. And it looks like my y's are going by about 10 each time. So let me show you the 2 ways I would do that. So y'all, the first way I would do it is to count how many x's I have. X times x times x times x. In the long run, that's a positive x to the 4th. Because all these x's are positive. So using the in behavior, I got an even degree and a positive lead coefficient. That thing should, in the long run,
Yeah, U-shape, go up.
be the U shape there. Now, the other way is I can go and graph this in my calculator and see what that looks like. So we know from the in behavior, it should look like this. Now let's go to the calculator and put the window on this and see what we get. So I'm going to share my calculator real quick. I'm going to go to y equals, and I'll put in the x times x minus 3 times x plus 2 times x minus 4. Now I'm going to go to that window and set it to what they got. So -10 and 10 is good for the x's. So I'm going to make my y's go from -100 to a positive 100. And that looked like they had 10 marks. So that had to be going by 10s on that. All right, y'all. So let's look at the graph. So look, it looks like a W, but guess what? Both of those outside ends are going up. So it looks like a W, but it's in the U shape with the in behavior. So we would go right to Math Lab. So y'all, A, B, C, or D?
D.
I'll make these a little bit bigger. So like y'all said, D, the one that looks sort of like a W, right?
Yes.
All right, 9, same thing. F of x equals 10x to the 3rd minus 4x squared minus 90x plus 36. Now, this one goes from -5 to 5, and then -250 to 250. And there's 10 of them, so it looks like the y's are going by 25 each time. But y'all check this out. My lead term is a 10x to the 3rd.
So it's odd. and
Odd
positive.
degree in positive.
So that's gonna be kind of like a S, like
Sort of got going uphill
Up,
left to right.
yeah.
So it looks like C or D, but guess what? C is crossing right through to 0. And do y'all see that plus 36 at the end?
Mhm.
That plus 36 is the y-intercept. So let's look at D. So D looks like that and would possibly be cutting
36.
across there at about 36. C is going right through the center. So we know it's going to be C or D. So we can verify that on this calculator, y'all. So let me go to y equals. I'll cancel that last one. So I had 10x to the third. Minus 4x squared. Minus 90x. Plus 36. So I'm going to set my window. Remember, my x's went from -5. So -5 to a +5. And then down here, my y's went from -250. So they're really zooming this graph out. And then 250 for the max. And there was 10 of them, so that had to be going by 25s. Usually they'll take the number and divide by 10 to get their scale. So let's graph it. So you see it is a little above the center right there. If you can see, it's above the center. So let's go back. So y'all, we got to go with D because see how that D is a little above the center? C is going straight through it. So we're going to go with D and then move on.
Mr. Eugene, can you tell me what you set the Y min as again?
The Y's on my Y's, let me pull my calculator up. On my Y's, on my window, I had -5 for the X's. And then that one was -250, +250.
Okay, hold on. Oh, so
Um,
you didn't put the 10.
Uh-huh. But look at this. Let me go back to the graph. It might take away my problem I did. No, it left it there. Look at these graphs. You see how they're, I'm just looking at these and going -5 to 5. See how they are on the X's?
Uh-huh.
And,
Oh.
and then the Y values. That's where I'm getting my window at, okay?
Got it. Okay.
That way you can match their stuff and get the picture just like they got.
Okay.
Right. So -1 and 1 are the two numbers. They want me to use synthetic division and determine whether they're zeros or not. So I got h of x will equal x to the fourth plus 2x to the third plus 2x squared minus 5x minus 6. So these are yes or no questions. So let's go do some synthetic division. So the first zero I'm going to check for is this -1. Then I'm going to write out all my coefficients. So I got a 1, a 2, a 2, a -5, and a -6. And then I'm going to box off. Remember, that's my remainder. So here's the question. If I'm going to put yes on this, that -1 is a 0, what's my remainder better be?
0.
Better be a 0. So I get 0 remainders. We got yes. We get anything else, we're going to put a no, okay? All right, so remember, synthetic division, bring that first number down and then multiply, add, multiply, repeat until we're done. So 1 times -1 is -1. 2 minus 1 gives me 1. 1 times -1 is -1. 2 minus that 1 is 1. 1 times -1 is -1. -5 plus -1 gives me a -6. Oh, y'all look at that. -6 times -1 is a +6. So I get a 0 for that one. So this one is definitely going to be a yes. So now we got to check the +1. So the same numbers, 1, 2, 2, -5, -6. Now I've seen this one go yes, 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 no, no, yes, but I've never seen a no, no for this one, okay? So at least one of these numbers will probably be a 0 for you. All right, y'all, let's check this and bring down to 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. Oh, it's getting close. 5 times 1 is 5. Negative 5 and 5 is 0. But y'all, my last number's killing me because 0 times 1 is 0. And negative 6 and 0 gives me a negative 6. So my second one is no. So I got a yes, no for that one. So let's go plug that in. So yes on a negative 1. Oh, y'all, look how they're being sneaky here. The first one, they got no on top, yes. But the second one, they got the yes on top and the no on bottom. That's pretty sneaky if you ask me. Trying to mix up the order of their answers. Oh, y'all got to watch that math lab, okay? Oh, we don't need to write this one down, y'all. Suppose I got a polynomial of degree 4 with rational coefficient, and it has the following given numbers as zeros. They want me to find the other zeros. So I got 2 zeros, I and 4 minus square root of 7. So do y'all know what my other 2 zeros are without
Negative.
doing any work?
Negative I
and
and then
negative.
negative 4. Or be
Negative.
4 plus
So negative
7.
I, comma. Now y'all don't change the sign of that 4.
Yeah, it's positive 7.
Uh-huh. And then that'll be a positive square root of 7. So only thing we sign on is the I part or the radical part, okay? All right, so y'all remembered that. Good job. All right, y'all, let me write this one down for number 12. So I got a square root of 2 and a 3i. So this one, they actually want me to find a polynomial function of lowest degree that has these two numbers as some of its zeros. So we're going to go to the pad for this one because they don't want me to just give the 2 other zeros. They want me to find that whole polynomial. This is where we had the FOIL, and we'll end up with something like this when we're done, okay? So one of the answers I know is x equals square root of 2. Well, guess what? I know this. If a square root of 2 is a 0, what else has to be a 0?
Is it the square root of negative 2?
Oh, you're so close, but put that negative on the outside.
Okay.
So remember, negative square root of 2. So the square root of 2 part will stay the same. All you're changing is the signs on the outside. All right, so good on that. And also, I know if this positive 3i is a 0, what else has to be a 0?
Negative.
3i.
Negative 3i. So this one was going off the material y'all knew from 11 that they had to be in conjugate pairs. So they're only going to give you the radical and the imaginary, and you had to know the other 2. So now, this is the one where I got zeros on the right side by doing all that subtracting and adding. So I get x minus square root of 2 equals 0. Here I'll add on both sides. X plus square root of 2 equals 0. Here I'll subtract 3i and get x minus 3i equals 0. And y'all finally will add 3i and get x plus 3i equals 0. So we got our factors. Now, let me move that cursor. Now that I had all these factors equal to 0, I'm going to put them all in parentheses and set that whole thing equal to 0. So I get x minus square root of 2, x plus square root of 2, x minus 3i, and then x plus 3i. All of that equal to 0. Now, y'all ought to be happy. I got the one with all the conjugate pairs on it. They had one that I was tempted, but it was like a degree 5, and it gave you numbers like 2, 3, and all that. Ooh, that would have been too much foiling. So since these are conjugate pairs, I can shortcut foil each of these instead of having to do the full foil. So the first one, x times x, y'all. What is it? X times x.
X squared.
All right. Negative square root of 2 times a positive square root of 2. That'll be a negative. So what's the square root of 2 times square root of 2 give you? And y'all can even ask your calculator that.
4,
So that would be a square root of 4. So what's the square root of 4?
2,
So this will give me x squared minus 2 in the first parentheses. So y'all remember that when you multiply a radical times itself, you get that number that was under that radical, okay? Now let me see what y'all remember about these imaginary. So again, you got an x times an x. X squared. Now, negative 3i times 3i is a negative 9i squared. Well, what does that equal in the long run?
A negative 9 squared, because don't you make that I a negative 1 or
So that I is going to be a negative 1. So what's that
Yeah.
negative 9 times that negative 1?
a positive 9?
Positive 9. So that this one gives me an x squared plus 9. All that equal to 0 still. So here's the thing, y'all. The radicals, when you multiply these radicals, they will always be negative. When you multiply these imaginary, they will always be positive, okay? All right, y'all. So now we got to foil these 2 times those 2. So let's see what we're going to get. X squared times x squared.
x squared. Or x.
It's x to the 4th, right?
Because 2 plus 2 gives me 4.
Okay.
X squared times 9 is a 9.
9x squared.
Negative 2 times x squared.
That's a negative x squared.
What, you still got sure?
Negative 2x squared. I'm so sorry. Yeah.
There you go. Now, negative 2 times that positive 9.
Negative 18.
Negative 18. Can you go further on this one?
Yes, because
Okay,
9x
x
squared
minus
and 2x squared.
There you go. So bring down our x4. 9 minus 2 will give me 7 of those x squareds minus my 18, all equal to 0. But y'all, all Math Lab is going to want is the little polynomial. Now, you ended up with an x4 because you had 4 zeros up here, okay?
Mm-hmm.
All right, so let me remember that when I go plug this thing in real quick. Go to 2, 3i. Okay, so all they're wanting is us to put in our x to the 4th.
Can you go back to the other page real quick?
Uh-huh.
And that's crazy. Them little 2 things got that big old.
Well, that was
All
2
the-
things in disguise. That was 4 in disguise, remember? But I always like these conjugate pair ones better than I like the ones where you actually had to foil it out and get 3 things. And then you had 2 things times 3, remember? And then you had to do another one times all that. So, woo, they get a little crazy.
Good, thank you.
Okay. All righty, so I got my x4 in. I need what next? Plus 7x squared. So let's see.
Minus 18.
Oh, I gotta get back in the box. My cursor went crazy. And then we had minus what?
18.
18. All righty, y'all. So then we go next. All right, y'all. So let me write this 13 down. So the polynomial has the given zero. That's that -3. They want me to find the other zeros. So I got f of x equals x to the third plus 3x squared minus 7x minus 21. And the number we're checking is that -3. So we're going to go do this one real quick, and then we'll come put that in.
Is this the synthetic division again?
Uh-huh. So we're going to start out with synthetic division because we got a degree 3. Once we sort of divide out that -3, those 3 numbers that we get for our quotient, we can then use the quadratic stuff for. So you got to use synthetic to turn this x3 and get those other quotients, okay? So you're going to try -3. They're giving me that. My coefficients are 1, 3, -7, -21. So remember, this last section will be my remainder. We're looking for what 3 numbers we'll get right here to do our quadratic stuff. Either factoring it, quadratic formula, or square root stuff. Now let me ask you this. They gave me a 0 of -3. Since that's a 0, what remainder will you better get?
0.
0, perfect. Y'all, if you don't get a 0 here, somewhere you definitely made a mistake, okay? Because they're giving it to us. So bring down to 1. 1 times -3 is -3. 3
That
minus
cancels.
3, 0. 0 times -3.
0.
Mm-hmm.
-7.
-7. And look at that. -7 times -3.
21.
And we definitely get our 0 remainder. So they're not worried about that, and they gave it to us. They want to see what we get out of these 3 numbers. So remember, since that was an x to the third, this now starts as the x squared. So I got 1x squared, 0 x's minus 7. So they gave me one of, remember, the degree 3 tells me I got 3 zeros. They gave me 1, so we got to find the other 2 right here. Set that thing equal to 0. And y'all, the easiest way to solve this, add 7 to both sides. Well, actually, it's the only way to solve this because 7 don't have a square root, right?
Yeah.
So you're not going to be able to factor it. You would have to do the square root here. So we get x squared equals 7, and y'all square root. So it's going to be a plus or minus square root of 7. So can you do anything to that? Plus or minus square root of 7?
No.
Nope. So that's going to stay plus or minus square root of 7. Now, watch MATLAB. All they want is the other zeros, which is what we got. Don't put the one they gave you in the answer blank, okay? Or they will mark that wrong on that MATLAB. So go to here. See, it says the other zeros. So does it give me, let's see, it gives me the plus or minus. So I can actually do my plus or minus 7. Whoops, not 7, but I need a
Square root of 7.
square root of 7. There you go. There y'all. So that'd be 13. Then we go to 14. So 14 and 15 are going to be finding the domains, okay? So this one, they're giving us f of x equals x to the 3 minus x squared plus an x plus 5. All of that over x squared plus 13x plus 40. All right, notice they want me to do it in set builder notation for ABC, and then on the bottom, the domain in interval notation. So they want this both ways. And let's go find my pad.
So it's gonna be comma. I mean, sorry, it's gonna be parentheses. X negative negative on both sides.
Oh, okay. So,
I mean, my bad. You gotta. Okay, I'm moving too fast. Go ahead, Miss Eugene.
well, you're sort of right on that though. But all we're worried about is the bottom, right, on the domain.
Right.
So take that bottom, set that equal to 0. And y'all, this one we have to factor, unless y'all like doing that long quadratic formula. But that's the x squared. Last one's positive, so both of these will be positive like the middle.
Oh, why did I think positives resulted in negatives? That's only negatives that results in negatives.
Well, when I'm done, I'll get some negatives.
Okay.
So y'all factors of 40 that add to get 13.
8 and 5.
8 and 5. So now remember, at this point, x plus 8 equals 0, x plus 5 equals 0. Now, both of these positive numbers, when I solve it,
Be negative 8.
negative.
-8.
And I get what? My negative 5. So these are the numbers I got to kick out of my domain is a negative 8 and a negative 5. So set builder notation, x such that x is what? A real number. And x cannot equal that negative 8, negative 5. Now this one wants you to put the numbers in order from left to right. So since negative 8 is less than negative 5, it would come first. Now interval notation, same way. From negative infinity to negative 8. Union around negative 8 until we hit negative 5. Union around that negative 5.
Until positive infinity.
Until positive infinity. So all of y'all's number 14s will start at negative infinity and end at positive infinity, and you'll have 2 unions in there. Alrighty, so the first part will be easier with the set builder because they write everything out. So since I got 2 numbers, I guess I would use C for that, wouldn't I? And they want ascending order. So here I would put my negative 8 and then my negative 5. And then down here in interval notation, parentheses, negative infinity, comma, negative 8, close parentheses, union, and then parentheses, negative 8, comma, negative 5, close parentheses, union, open parentheses, negative 5, comma, infinity. I'll tell y'all the truth. It almost takes more time putting in the answers than it does working these things.
Yeah, it does.
Y'all notice that too, huh?
Yeah.
Oh my God. All righty, y'all. Let's see what's next. 15 will be another domain, but this one on 15 only wants the interval notation. So let's see what we got. F of x equals 3 over x squared plus 3x minus 28. Now, I will say everybody's number 14 will be positive at the last number. So they'll either be both positive like the middle or both negative. These number 15s, the last number is always negative. So that means when you work this one, you're going to have unlike signs when you factor it. So set it equal to 0. And then we're going to factor that thing. So x squared again, x and an x. Remember, that's negative, so you're going to have unlike signs. The larger number will be positive like the middle number. So what's
X plus 7, x minus 4.
So x plus, I think you said, I remember that I heard the x minus 4.
X plus 7, x minus 4.
X plus 7, X minus 4. So y'all, they multiply to get that 28. They add together to give me that positive 3. All right, so now we're just changing signs. Set both them equal to 0. So -7
4.
and a positive 4. There you go.
So it'll be x of x or x.
So remember, interval notation, negative infinity. Who's first?
-7.
7.
So that's union around -7. Then we'll hit our
-7 and 4. And then
uh-huh.
4, and then 4 to positive infinity. I
And
mean,
then
you
4.
win, and then 4 to positive infinity.
You're good. There you go. All right, so we would go put all that in MATLAB. So here's another long one. So parentheses, negative, infinity, comma, -7. Close that one in union. -7 to 4, you said. And then union and parentheses, 4
to positive infinity.
positive infinity. There you go. Ooh, that interval notation ain't no joke. And think if you had 3 numbers or more, y'all, that would be a lot of unions in there. Okay, so this is one of the longer ones. We got R of X equals 7 over X squared minus 4. Now, I will say this. The first one wants the vertical asymptotes. This one where it says the oblique asymptote, every single one of y'all on this question, when it asks for oblique asymptote, you got to put B. There will be no oblique asymptotes for anybody, okay? So what we got to go find is our vertical and our horizontal. So let's go to the pad. So y'all, to find the vertical asymptote, you're going to take the bottom of this and guess what? Set it equal to 0. And I'm going to solve this by adding 4, but this would be perfect squares because the 4 would have a square root on that, okay? So I'm going to add 4 and do it to square roots because I think that's a little quicker. And then if I take square roots of both sides, that'll be a plus or minus square root of 4. So that I get x equals plus or minus. There you go. So MATLAB, oh, I'll look when we go. It might take it with a plus or minus, or we might have to do this. X equals 2, X equals -2. So we'll look at how we got to do it when we get there. Now, there's no oblique, but there is a horizontal asymptote. The horizontal asymptotes, I gave you 3 cases. The bottom had a higher degree than the top. The top had a higher degree than the bottom, or they had equal degrees. Well, y'all, look at here. The degree of my bottom is a 2. There's no degree on top because it don't even have a variable. So for this one, my bottom degree is greater than the top degree. So y'all, what did we say when the bottom was a higher degree than the top? Y equals
0.
0. There you go. All right, y'all. So let's go put that in. So 2, -2 for the vertical, 0 for the horizontal. So they do say type as equations. So I'm going to have to do my X equals, what was it? 2, comma,
Plus or minus.
X equals -2. There you go. Okay, there's no oblique. The horizontal, y'all told me, and it's an equation also.
Y equals 0.
Y equals 0.
Now, Mr. Eugene, before you move on to the graph, after this, I wonder if it's a way you can tell us if you got A right. Like if we supposed to put x equals 2, comma x minus 2, or if we supposed to put x.
Do y'all like shorthand better?
It don't matter.
So I could use that. You
Plus or
see,
minus.
let me tell you how you can tell. You see, I'm in that little box. I got my x equals.
Mm-hmm.
Well, what are they not giving me down here?
You right. They ain't giving you a plus
Plus
over
or
minus.
minus.
They're not giving me that plus or minus.
Mm-hmm.
So MathLab's being a little cruel on this one, and I'm going to have to write that whole thing out.
Okay, I got it. Now I'd be messy and click that more button and still add. So I got you though.
Yeah, I don't think it would have it on the more on that one. Let me go back in the box. Well, I'm not seeing it nowhere, y'all.
Oh no, they don't have it. Okay, okay, bitch.
No, so see, they being sneaky on that one. Now, remember, we had asymptotes at -2 and 2. So it's got to be A and B because they're the only two that got these dotted lines at them points. But y'all look at this. I'm gonna go graph this real quick and look at this. It goes from -4 to 4 on the X's. And then my Y's is that a -7 to a +7. So let's go graph this and then we'll know exactly which one this is. But I'll tell y'all what, it's either A or B because we over here they only got one asymptote on C and D, and we had 2. So let's go graph that. So I'm gonna go Y equals, clear that one out. So y'all remember how I can make this look like a fraction?
Yeah, you do alpha and then you do y equals n over d.
There you go. And then I had what on top? 7 on top. And then I go down and I had x squared minus 4. All right, so let's go set that window. They had -4 to 4 on the x's. And then -7 to 7 on the y. And I'm gonna put them ones going, the y going by 1 again instead of 25. Ooh, that you couldn't even go 25, you only go into 7 on it. So yeah, change that into 1. And let's graph that. So look, ours has the parabola part in the middle upside down. So remember, that's upside down. So that would have to be A. B, they got it going like a U. And then the other two are totally gone, okay? So y'all, a lot of this just getting their graphs perfect is just setting that window for you, okay? All right, so let me write this one down. This is 17. Vertical asymptotes, g of x equals x to the third over 3x to the third minus x squared minus 14x. All right, so I'm going to go solve it. Now, this is probably the other trickier one on this test. But vertical asymptotes, we set the bottom equal to 0. Now, what's getting us on this one? The first thing I got to do to factor this.
Descendant order.
Well, we are 3, 2, 1.
Oh, wow.
But
Okay.
what do all three of these have in common?
X's.
X's. So I'm going to bring out 1x. And that's going to take 1x away from everybody because remember, we're dividing those. So x3 divided by x squared leaves you 3x squared. X squared divided by x leaves you 1x minus 14x divided by the x leaves you to 14. Now, check this out. X to the third is really what? X times x times x. So y'all remember, a vertical asymptote gets canceled out if there's a factor on top that matches a factor on the bottom. Well, that means one of these x's on top is going to cancel out that x. So we're only going to get the two asymptotes we get from this 3x squared
So it's only gonna be 3x? Oh, it's
minus
okay.
14 equal to my 0. So, well, on y'all's, when y'all get an x to the third, one of those x's is going to cancel out with that top, okay? Everybody 17 will have one cancel out, so that your two asymptotes are going to come from this equation. Now, we haven't factored a whole lot when there's a number in the front, but y'all, I'm about to show you. The x squared would still be an x and an x. The last sign's negative, so that'll still be a plus and a minus. But let me show you the difference now. We're not looking for factors of 14. When you got a number in front, you got to multiply 3 times 14, and that's going to give you 42. 42 is the number that we got to find factors of that'll give me a 1 when you subtract. So y'all, how many ways can I get 42? And remember, you can do 42 divided by x on the y equals and get all the factors. But 1 and 42 are factors. 2 and 21. We know 3 and 14 are. What's left?
6 and 7.
6 and?
7.
There you go. And guess what? 6 and 7 have a difference of 1. So those are going to be my numbers. Now y'all remember, 7's larger. It's going to be negative like the middle. So bring that 7 over here and that 6. So here's the difference in factoring with a number in front and without a number in front. Since you multiplied the 3 by 14 to get to 42, we have to divide the 3 out of both of these numbers. Now, can you simplify that one?
To 2.
That's a 2. Guess what? Can't simplify that one. So that's going to stay x minus 7/3. Now, since these are vertical asymptotes, take both of these factors and set them equal to 0.
I got a question real quick. You're dividing by 3 right there. Where'd you get that 3 at?
Right. I was just about to ask that.
Oh, this 3 right here?
That
Because,
threw me off a minute.
okay,
Oh,
you see this 3 in the very front?
Yes.
So I had to multiply the 3 by 14 to get the 42.
Right.
So once I get my two numbers that equal 1, I got to divide that 3 back out of them two
To
numbers.
keep it balanced. Okay.
So you're multiplying it to get the number, and then you're dividing it out of those factors. So it's like you're sort of borrowing it, but then you're giving it back.
I see. Okay.
So y'all, guess what? This one gives me x is a -2. And here I'll add 7/3. And I get x equals a positive 7/3. So remember, on 17, you're only going to get 2 vertical asymptotes. This x is always going to cancel with your top. All right, y'all.
I have a question.
Uh-huh.
So, because normally the higher number goes on the left, why is the higher number going on the right? Is it always going to be on the right for this?
Oh, no, it depends on the higher number out of these two numbers has to be the same sign as the middle.
Okay.
It's just because I put my negatives on the right side. But if I'd have done this, x minus and x plus, I always start plus minus in my head. But if I'd have put minus plus, then I'd have made my 7 first and my 6 second.
Okay.
It's just how you put your signs there, okay? That's the only thing I'm looking at. That -7 had to be negative, and the 6 had to be positive, because the -7 positive 6 equaled that -1.
Okay.
Okay. All right, y'all. So let's see. We go throw that into 17 here. So let me see what they do here. So guess what? Now they give you the plus or minus, but I got two different answers. So -2, comma, and then I had what, 7/3. So ain't math rab cruel. The one where I couldn't use the plus or minus, they give me the plus or minus, and the one won't go where I could have used the plus or minus, they didn't. Now y'all notice they gave me the x equals already, so I just had to put in my two numbers, okay? All right, 18. Oh, so we don't have to write this one down. This wants me to determine the horizontal asymptote. Well, the horizontal asymptote had three cases, like I said a while ago. If the top's bigger than the bottom, is the bottom bigger than the top, or were they equal? So y'all, is this one bottom heavy, top heavy, or are they equal?
If we're looking at the threes, they're equal. If you're looking at the exponents, the bottom is bigger.
Oh, guess
The
what? I'm looking at the
bottom-
exponents.
Okay, so the
Okay.
bottom is bigger, so this has no horizontal asymptote.
Oh, hold on now. Remember, the bottom's bigger.
Oh. Okay,
So
yeah,
y
yeah.
equals 0.
Y equals 0. So remember, bottom heavy, y equals 0. Top heavy would be no horizontal asymptote. And then if they were equal, we would look at the lead coefficients in the front. So say both of these were x to the fourth. Say I had a 1x4 minus 3 on top, 4x4 plus 3 on the bottom. This one would be 1/4 because you would look at the lead coefficients, okay? But no, anytime it's bottom heavy, put me a 0 in there and then move on. All right, so that means the last two are doing the inequality stuff. So x minus 2 times x plus 4 is less than 0. Now remember, they want these answers in interval notation. So y'all remember on these ones here, 19 and 20? That's where I made the number line and stuff. So let's solve both of these first and get our two numbers. So it looks like it's going to be what, a plus
X
2
2, x -4.
and -4. So then I made my number line. And I'm using those two numbers. So -4 would be first and a 2. So y'all remember what I tested one number every time.
0.
And y'all, that 0 is going to be in between that -4 and 2. So I'm going to test 0 up here in this original equation. If it's true, I'm going to shade that area. If it's false, I'm not going to shade that area, which means we're going to shade both ends of this, okay? So let's test our 0.
So it's -2
Uh-huh.
less than 0. Yes.
Oh, put a 0 in here, and then you're going to multiply that. So if you put a 0 here, you get -2. You put a 0 here, you get 4. Both those have to be less than 0. So what is a -2 times a 4?
-8.
-8.
So
It's true.
-8 less than 0. Is that true or false?
True.
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 That is true. So I will shade that where that 0 was located, okay? Which means we're going to shade that thing right there in the middle.
Mr. Eugene, I don't know about nobody else, but I didn't get any shade things. I got the equations, but they didn't ask me to shade anything. Is that normal, or is that something that's gonna be different on the test?
Oh, no,
Mine didn't.
No, you're not going to get the number line stuff. All you're going to get is the answer in interval notation. We're just using this number line and shading it so that when I'm done, I can put my answers in interval notation.
Okay, okay. Oh, got it. Okay.
Now, here's my second question. Would I put parentheses around these numbers, or would I put brackets?
Parentheses, because there's no underline underneath.
There's no equals under there, so they got to be parentheses. Good job. So that means my interval notation will look just like y'all got right here. Parentheses -4, comma, 2, close parentheses. So that should have been what MATLAB was wanting out of you. Right there. So yeah, they didn't give you, I'm just using this sort of to test my numbers and stuff and then write it in interval notation.
And for
Okay.
this one, you can't do you can't flip-flop them because otherwise you'll get it wrong.
Exactly. They got to go in order
'Cause I
from
did that
left
a
to
few
right.
times.
You got to
Yeah.
treat that number line like you're going down the number line, starting at negative infinity, heading towards
Positive.
positive infinity. There you go. And so if you put B on this one, you're going to miss it. This one does have an answer. So -4, comma, 2, close parentheses. All right, y'all, let me see what 20's got here. 20 has x squared plus 20 less than 4x. All right, so let's go work this one. So we're solving this one, y'all. So guess what? We need a 0 on the right side. So y'all would have to what? Subtract that 4x from both sides. And I'm just throwing it in the middle because none of these are like terms. So I'm just going to bring down my x squared and then my -4x and then plus 20. All that's going to be less than 0. All righty, so we need to get our two numbers so we can do our number line. And then at this point, I'm going to set it equal to 0. So I got an x and an x. Since this last number's positive, we're going to have like signs. And these two factors will have the same sign as that middle number. So both of these are going to be negative. So y'all, find me factors of 20 that add to get a 4. So let's see, what makes it 20? 1 and 20. 2 and 10. What's next? 4 and 5. So which one of those will add to get you a 4?
The 4 and 5. The 4 and 5.
Well, if you add them, you're gonna get a 9.
Yeah.
Well, I was thinking -4.
None of them.
No, because remember, they're gonna have like signs, so even if you made them both negative,
-2 and -10.
but that's gonna give me -12.
It's gonna be
What?
B. It's gonna be B. It's no
Because this
solution.
one does not factor. There you go. So it does not factor. So remember, when it did not factor, we said this was a no solution.
With
No
the 0
solution.
with the line through
The
it.
0 through the line through it.
Yes, I messed up on this so many times. I was so mad. I'm like, you petty. You just want a 0 with a line through it. I kept putting 0. I kept putting.
Oh
Yeah,
no,
I
it's
did
just,
that
well,
box
it's
It's right
very
there.
empty set they got down here.
Yeah, I didn't know that. I was like, x equals 0, 0. What you want me to say?
Yeah. I don't know if there's a way to make a 0 with a line through it on a computer here. Yeah, so
No.
that wasn't getting you.
When it showed me the correct answer, I was like, oh, that's what you want me to put on there.
There you go. Yeah, that's the test, y'all. And number 20 has always been that on every one I've done today. So then we would just submit it and be done. So let's go.
Okay, Mr. Eugene, 20 out of 20.
So y'all did good on it, didn't we? All right, so I'm gonna quit that recording so I can get that sent out later.